Hi guys, welcome back to A Case of Econ Struggles. Today I want to keep talking about Edgeworth boxes. I also want to talk about the social planner problem. And one thing I want to talk about with Pareto optimality is this idea that Pareto optimal is what's efficient but not necessarily fair. And I want to talk about how we can sort of modify our existing model to take into account what we think fair or equitable and sort of think about how those values can make their way into economic models, because a lot of times people say, well, you econ people just want to make the most utility for the most people. You don't necessarily care who wins and who loses, but there is going to be, in fact, a way to introduce sort of those values, those morals of equity into these problems. So I want to talk about how we can do that. So timestamps are below if you would like to jump around, but let's go ahead and get right into it. And so I want to start with sort of the way the economic model is set up, and I'm just going to use a really basic example, just with some assumptions about well-behaved utility functions. And with those well-behaved utility functions, what we get is we sort of get this contract curve that I've shown here, where a contract curve, again, is just all the points, all the sets, all the allocations that are Pareto optimal between person A and person B. So just to highlight what I was saying sort of at the beginning, was that with this Pareto optimal set, if I use the green dot or the light blue dot, well, I'm giving everything to one person and nothing to the other person. So those are Pareto optimal because, for example, at this light blue point here, I can't make person B better without taking something away from person A, and so I made person A worse off in terms of making B better. So it's Pareto optimal to give everything to one person. But again, you might say, well, that's not necessarily fair, especially maybe if person A is already pretty wealthy, maybe person B is not as well off. How can we add these sort of ideas of fairness or equity to this social planner problem? And so in order to do that, let's think about more broadly how this social planner problem works, or how this Pareto optimal allocation sort of works. So the way you can think about it is if we go back to that example with Eng and Katara, which we solved the equilibrium allocation for, if we think about TOF as a social planner, we can think about it as almost what's happening is Eng and Katara are going to give their endowments to TOF. They're just going to give everything they have to TOF. And TOF is then going to reallocate or assign how much Eng is going to get and how much Katara is going to get, thinking about their utility functions and thinking about TOF as a social planner, what her objective is as well. And so one thing we might ask is, well, what exactly is TOF's objective as a social planner? If we think about more of the traditional Pareto optimal sort of definition, that would be total utility. She's trying to maximize total utility for both these people. And so that might lead to a case in which maybe you give Aang everything because maybe Aang's important, destined to save the world or something. And you don't give as much to Katara because she's really just there to support Aang or something. Maybe you give more to Katara because she's dealing with a lot. And you don't give as much to Aang because he's so gifted and he's got a lot of other stuff going on. Now there are other objective functions you could give to Toph. Toph could say, well, maybe I don't care about total utility. Maybe I care about average utility, or a weighted sum of utility. Maybe Toph cares about equity, so making sure both Aang and Katara have the same level of utility. Those are all things we can add to the social planner problem. The way we're going to add these things to a social planner problem is called a social welfare function. And now I'm just going to make that more formal and say, well, if you're trying to maximize total utility, then your social objective function is to maximize UA plus UK. If you're trying to maximize a weighted total utility function, maybe you're going to do the same thing, but now you're going to put weight alpha on Aang and 1 minus alpha on UK, where alpha plus 1 minus alpha is equal to 1. And so generally alpha is less than 1, but greater than 0. Again, these can be equal. So that's just like a weighted sum of utility. Maybe what Toph cares about is equity, and so then she's going to have this perfect complement social welfare function, in which she wants to equalize the utility to Aang and the utility to Katara. And when Toph is going to assign these goods or set out these allocations, what we can do is we can translate from an Edgeworth box diagram to what's called a utility possibility frontier or utility possibility set. What we're going to do is just for every allocation on this contract curve, we can think about, well, what's the utility here for Aang and what's the utility here for Katara? And we can plot that on this graph where the x-axis is the utility to Aang, y-axis is the utility to Katara, and we can sort of plot out and see, well, on this frontier, these are all the Pareto optimal points. The points inside this UPF are just all the pairs of possible utilities from this Edgeworth box. So now we can think about finding Pareto optimal allocations as we're going to take this social welfare function. We're going to use the fact that the markets have to clear, and that's going to tell us what exactly our Pareto optimal allocation is going to be. And so graphically, we can just combine this UPF with the social welfare function, find where they're tangent, and that's going to tell us the Pareto optimal allocation. So for example, here's that same example where I've got this UPF on the left-hand side, and I've got some sort of iso welfare, or basically lines in which the amount of social welfare or TOF's objective function is at the same value. So for example, right here in pink, here's the weighted sum of utility, and you can see its tangent right about here at this black dot, so maybe that's the Pareto optimal or the social optimal allocation when we're using a weighted sum of utility. If I care about equity, or if TOF cares about equity, she's going to have perfect complements at sort of indifference curves, which look like that. So maybe this point right here, maybe that's the Pareto optimal or the social optimal when we care about equity. Maybe it's also equal to the optimal utility that we get when we're doing a sum of utility. So again, all we're doing is we're taking the UPF, we're showing where it's tangent to TOF's social welfare function at the highest social welfare we can get. That's going to tell us what our Pareto optimal allocation is, given a particular choice for a social welfare function. And so I realize up until now this is sort of abstract. What we're going to do next is we're going to go back into that example with Aang and Katara, where we found the equilibrium allocation already. We're going to impose a couple different types of social welfare functions, and we're going to think about what the Pareto optimal allocation is under each one of those social welfare functions. So if you want to see that video, again, make sure you check out the original equilibrium allocation for Aang and Katara. Put a link to that video in the description below and in the top right corner. If you want to see this video, make sure to like this video, make sure to subscribe, hit the bell so you don't miss any new videos. If you got questions, put those in the comments below. We'll see you next time for another case of Econ struggles.